Okay, great. Good evening, everyone, or good morning, depending on where you are. And yeah, first I want to apologize for not being able to host the meeting last night, yesterday evening. My son has the school has some activities, so parents need to attend. So I asked Yi to host our meeting today. So no, I know some of you may not be able to attend today today's meeting, and so that is some inconvenience there. So I apologize for that. But hopefully, no, we are going to have a great session, and let's probably wait for 1 or 2 minutes before we get started. In the past 3 weeks, right? So Shanshan had been working on some really exciting tutorials regarding labeling. So if you remember, 2 weeks ago, we were given a talk about the image and label and text labeling and some of the autonomous or semi-autonomous tools were discussed, right? In today's meeting, Shanshan is going to offer us some tutorials on mainly manual labeling, of course, enhanced by AI tools. Okay? So in the future, probably we are going to be in the domain of AI-assisted labeling, because if the AI can fully automate the task, then we don't need any human to provide ground truth. But still, AI is far away from being perfect. There are always going to be some judgmental points that a human needs to intervene. And to train state-of-the-art models, really many researchers believe is not we need more algorithms, right? We have tens of thousands of algorithms already. Of course, there are going to be new algorithms being developed, but the bottleneck actually is the data. And that probably explained why many people found the ChatGPT model, the GPT-4 model, or even 3.5 model tend to be a lot better in performance compared to most of the open source models, such as Llama 2, etc. The key point is not really because of the model architecture, because they tend to converge nowadays to causal modeling plus the reinforcement learning with human feedback. But the data is a key issue. So we need a lot of human power to label those data, to make sure those data are in a good format, they are useful, they are accurate. And for open source models, usually people don't have the resources to hand code that much data. So that potentially is the bottleneck. Although, open source language models are catching up, but it may take probably a few years before they can be even comparable to proprietary data models such as OpenAI models or Anthropic. Okay. So that speaks to the importance of labeling. Okay, so let's get started. Shanshan, the floor is all yours.
Thank you, Dr. Wang. Hello, everyone. I'm Shanshan. I'm a PhD student from UNT Health Science Center. Today, I will give a presentation on image annotation and labeling. You can scan this QR code to get the slide and the code we will use today. Here are some examples where image annotation can be used. It can be used for autonomous vehicles, medical diagnosis, and public surveillance. Today's presentation, I will cover 3 parts. First, what is image annotation? Second, image annotation tools. I will include some commercial tools and open source tools. Then the last part, we will do some practice. First, what is image annotation? Like last time, when we've already learned something, autonomous data labeling. So image annotation is when the data is image, and then we label them. This is image annotation. Image annotation, in another word, is computer vision. It is used to model or understanding the visual world by extract useful information from digital image. My understanding is computer vision is an independent area from artificial intelligence. We know the relations between artificial intelligence, machine learning, and deep learning, but because AI is more powerful now, so we can use AI to help us do the computer vision tasks, and those tasks include image classification, object detection, and segmentation. I will give a brief introduction of these 3 tasks. So first, object detection. It's used to identify the presence of objects within an image or video. Usually, we use a rectangle to do object detection. And image classification. This is, I think, this is the same purpose when we do machine learning as classification. And image segmentation, it's used to assign a class to each pixel or group of pixels using image segmentation masks. And segmentation masks is a specific portion of image that is isolated from the rest of image. So the purpose of image segmentation is to simplify or change the representation of the image into something more meaningful or easier to analyze. There are 3 types of image segmentation, including instance segmentation, thematic segmentation, and panoptic segmentation. Because segmentation is defined by pixels, so pixel is the smallest element of a raster image that we can manipulate, and voxel is a 3D. We can understand it as a 3D pixel. So instant segmentation is used to identify individual objects in an image, and every instance is uniquely identified, and each pixel in the image is assigned to a specific instance. But thematic segmentation does not differentiate instances. It only cares about pixels. But panoptic segmentation is a combination of instance segmentation and thematic segmentation. Next part, I will give a brief introduction of annotation types. There are 4 basic annotation types: bounding boxes, key points, polygons, and polylines. So bounding box is usually rectangular boxes around an object. We use it to identify 2D images. If we use 3D images, we can use 3D bounding boxes, also called cuboids. And polygons is irregular shapes that can help us outline complex shapes. I think it can be used for image segmentation. And polylines, it's literally straight or curved lines, and it's usually used for autonomous vehicles to identify roads or streets. And key points is used to capture the features or landmarks, and in some softwares, they have another annotation type is skeleton, which is similar to key points. In future slides, I will introduce some commercial tools and open source tools. We can we can categorize image annotation into data annotated by humans, automated data annotation, and a combination of machine learning and human expertise. And as usual, I think for the software, it can provide the 3 types of services. For CVAT, which we will learn today, it provides a service for manual annotation and also AI-assisted annotation and autonomous annotation. So here, this slides, I listed some commercial ones. The first one, it's not an annotation tool, but it's an annotation platform, and it can provide some workforce if you want more people to help you to annotate your data. And Hive AI, Scale AI, Labelbox, those are like big popular annotation tools, work with some big tech companies. I attach the links if you're interested. You can explore yourself. There are also a lot of open source annotation tools. I listed some of them, and I choose CVAT to learn today because CVAT is supported by Intel, and it's under the OpenCV umbrella, and we can like use Python to use its API. So that's the main reason I choose CVAT. And VGG image annotator, and many people recommend that, and Dr. An has experience using it. Maybe after we learn CVAT, Dr. An can share his experience of using VGG image annotator and like maybe the difference between the two. And Label Studio is also a famous one, but I don't have the time budget to explore this, so we will only learn CVAT today. As I mentioned, CVAT is under the umbrella of open source and OpenCV. OpenCV is an open source library, and it has many like resources and also free courses. If you are interested, you can explore. And the data I used today is from a cargo, and I only choose the 50 images of cat and 50 images of dogs. We will use it later. And then next, I will walk you through those steps to use CVAT. Okay. First, we will create a new project, then a new task, then define some labels. Okay. So here, this is the interface of CVAT. I already created 2 projects, but we will create a new project here. If I click this, we can create a new project. Then we can make animal maybe. Then we can create some labels here. First, dog. And we can also add attributes. We'll ignore this first. And we can also choose the type of annotations. But if we choose rectangle, then this label will only can do for rectangle. So we just like by default, we will choose any. Continue. We can add another one, cat, and we can choose color. And add attribute cat. I already have this black cat. Then choose black cat test. Black cat. Okay. What? Okay. Okay. Continue. Now we have 2 labels, dog and cat. We can also, if we want to make it more complicated, we can use advanced configuration and submit. Now we have a project called animal, and we can add like more description, and also we can add more labels. And for the skeleton, I mentioned in the slide, skeleton is like very similar to key points. We can add a skeleton here and add image to define the skeleton. Annotations. Annotation that's can define here. So we have a this is help us to define the skeleton. Okay, yeah. Let's make just choose 4 points. Okay, continue. Then we have a skeleton. This is a project, but if we want to do image annotation, we still have to add task here. Create a task. Cat. Under the project of animal, we create a task called cat, and it will then we can upload some photos. Just to choose 5, maybe 10. Then we can upload those images here and submit. Now we have a new task called cat. Here I want to emphasize we can also add a new task called ground truth. This task can help us to do data quality analyze. So ground truth, and it will choose randomly from the image I just choose, and it choose 5. Choose 5. Usually by default it will choose 5% of the images to be the ground truth. So we only choose the default setting. Oh, no, create a job. Why? Maybe 5. 5. Now we are in the. Now we will do some data. We created a task under the project, a new task under the project, and we also created a ground truth task, which will help us to do the quality control. Next step, we will do some different types of data annotation, including a bounding box, polygon, polyline points. And if we have time, we will do a video annotation here. So we can get familiar with the interface first. The left part is a control sidebar. The top is a top panel, and on the right is the object sidebar. This tool, rectangle. This is for us to do the rectangle, and we can choose shape, and the label we can choose cat or dog. Now we have cat. No, we have dog and shape. Then we just have to click and drag and click again. Then we have the we have annotated this image, and we can also edit it. If we use the wrong label, we can correct it, but it's dog. Then we can here forward. We can choose the next image. We can try polygon. Polygon cat. Then number of points. We don't choose. We use default polygon. Shape. We just click and polygon. Polygon is a shape. Polygon is not aligned. So we can also every time there's new point, I will click my mouse, but you can press shift. You can press shift key, then just move. It will automatically add points here. So and here, and enter and press N, later N, finish. Then we have a new annotation polygon, and we can edit it here. Also, we can use here, we can change the appearance of the annotation. Let's show bitmap, it will become black and white, and also the change the opacity. Then we finish the polygon. Next figure, next image, we can do polyline cat, then shape, and use maybe the ear. You see the difference between polygon and polyline. It's line, not shape. Then press later N, finish. Next one, we will try skeleton. Oh no, this one is points. We can try points. Points is slightly different from a skeleton. If we use skeleton, we have to define it first, then use skeleton. We can use points shape.
Sorry to interrupt you, Shanshan. I had a question.
Yes.
Why did you choose the black cat label or the dog label? Is there any specific, like, why did you choose that? We can choose any arbitrary value for the label, or is it just for like
Oh, you mean I define the attribute first, right? Okay. This is now we are doing the object detection. This part is object detection. We draw the rectangle, and we can choose the label. We can choose the label here, dog or cat, and we draw the rectangle for the purpose of object detection. But we can also do image annotation. We can also do image classification. I will show you here. If this is a dog, then we annotate the dog. Then we can choose. Here. We can choose a view and attribute annotation. And for dogs, we have. For dogs, we should have a. We should have attribute, but I'm not sure why here we cannot choose. Let me check. We can save. And on the top project task, we have the animal project. We just created this animal project. Then
exactly. Here you have like the black dog.
Yes,
label.
I think I may not successfully created it. Let's edit it. I think I didn't successfully add attribute. Let me do this again. Color. Select a text, then default value black. Then add another attribute, color. Attribute name should be unique. Mutable, no sure. Gender. Okay, no sure. Next, gender female. No. Let me see if I can down. See if I successfully, yes, now we have the attribute. Let's go to our, this is the task we had on the animal project, and we have 2 jobs, ground truth and the one. Now we annotate dog, see dog, and then we check attribute. Oh, see here. We can do an object detection by draw this rectangular or polygon polyline, but we can also choose attribute annotation. This is for this is not for object detection. This is for image classification. For some images, like you can see a dog, a cat, but maybe some like age, maybe you cannot. I'm not sure. Maybe you cannot do this by detect the image, but you have to do this yourself. Like usually they do some age groups, like young people or something, gender, for these attributes.
Right.
You cannot get this information from the images.
Yeah, so just adding to that and response to Shanbabi, your question. So no, as Shanshan mentioned, the attribute I guess is for classification. So you could think of you can have a binary classification problem or multi-class or multi-label classification problem, right? So example here, the default text is black, right? So we say, well, no, we want to differentiate dogs by their color and by their gender, right? So for a specific image, so say for example, this dog is definitely not black, it's brown, right? And then is say a female, right? And then your model is trying to make a prediction, right? Based on the image the model sees, the model try to predict its gender as well as the color, right? So if that makes sense, right? So that is the annotation. So the choice of the color attributes and its text is completely based upon your task. For example, if you want to predict gender, and then you may have like female dog or male dog. If you want to predict, say, the age of a dog, and then it could be a continuous variable. This dog is 5 years old. The other dog is 2 months old, etc. Right? So the text is, you could think of a text is label, right? It's like text label pertaining to a characteristics of the dog or the cat.
Okay, that makes sense. Thank you so much, Professor.
Yeah, sure. And then Shanshan, could you I have a question regarding the differences between project, tasks, and jobs. Could you explain how they differ? And do you have like one project, and then under that you have multiple tasks, and then for each task you have multiple jobs? Is how you classify them?
I think it's just like a folder. You have a big, like the big folder, and that is project. Then you want some subfolders. Those subfolders are tasks. So we have the biggest folder is animal. We created. Then we want to create some subfolders. Then so we have the first subfolder is cat. Then we can have, like here, add more subfolders, tasks, different tasks on the project. Then after we have the task, we can have different jobs. That means if you have like 200 images you want to annotate, but you want to divide these images. If you have like 5 people can help you, then you can divide the 200 images into like 10 portions. Then you can like assign, everyone can do the 2 jobs under the task. So you have the task is 200 images. Then you can divide the task into like 10 jobs. Then you have like people help you. You can like ask every of them to do 2 jobs or 1 job. So as project, then project has task, then task have jobs. And job, one important thing is ground truth is 1 job is ground truth. That's we use for quality control.
So the ground truth. Right. So you mentioned the important perception. Yeah, I think that makes a lot of sense. Like you could think of them as like a big folder of everything, and then so if you have a classification problem, then you separate into 2 tasks, right? One pertaining to dogs, the other pertaining to cat. and then you can subdivide them into into different subfolders of images, right? So you can assign them to different people to work on. And then could you explain a little bit about the ground truth? Ground truth means that they are like the examples that say, if you are the principal investigator, you annotate them, and that set serve as the ground truth. Is that the meaning for ground truth?
I think it's the ground truth is to help us to do the quality control. Because if you have, for example, you have 1 million images, maybe you cannot do those images manually. You have to maybe choose 5%, maybe, or like 100 images. You choose randomly from the data set. Then you can make sure the quality of the ground truth, only 100 image. You can check every image. You can make sure the quality. Then the other part, the remaining images, you can use like AI assisted or autonomous annotation. Then you can compare. You can compare those annotated by AI and compare with the ground truth, the small set. By comparing, you can check the quality. This is all the tasks I have, and I click the dots and you can see the view analytics. And this is a task. You can only see the task here. No, we have to check. Oh, because this is already ground truth. We can check here. Guess it's not. We can go back to project. I think here. Then this is a task. This is a task. Then we check view analytics. Here, this analytics has two parts. One is performance, another quality. Performance, you can, if you have like 5 people or like work for you, you want to check their progress, you check performance like every day, how many images they annotated and change. Then quality. Quality is like the statistics by comparing your ground truth with like other jobs, and they will compare like I'm not sure how they get this. They may have some like calculation. Then they see the other annotations compared with your ground truth. If there's conflicts, maybe you can check. And also interesting part is that is for teamwork. For teamwork, we have like a lot of jobs, and if you have like me or other people, you can assign these jobs for different people. And also like what's this job for? Is this job for probably first we have to do the annotation, then like the second people do the validation or decide if we accept or if we change. That's also like one like important step for quality control, I think.
Right. So this is a great point. So I'm guessing, right? I may not be right. I'm guessing the ground truth means, say you randomly choose 5%, right? So if you have 100 images, right, and then you randomly choose 5 images, and then you as the primary investigator, you label them, and your label serve as the ground truth, and then you send those 100 images to 5 people, right? So each people get 20 images. Now within this 20 images, that might be 1 or 2 images that are from the ground truth, but that person doesn't know. That person just label them as if they were like a new image. Right. And then after that, the model is going to, the software is going to give you a statistic showing the alignment between your ground truth image versus the other people's labeling. And then, for example, you label as a dog and the other person label as a cat, then there's a mismatch, right? So that means that you have a ground truth that's violated. I guess that was what's happening behind the scene, but I'm not 100% sure.
Right, I guess so. That makes sense because ground truth, those images are from the first job. The first job is 100 images, and ground truth like choose them, and those like tasks like that, like those images are still there, so they will have some those ground truths will be annotated twice for this task.
Okay, great.
Then project will go back to our animal cat. Then job here. Okay. Standard. We've tried rectangle, polygon, polyline, and points. Points is easy if we want to capture some points, dog, cat, shape. If we want to capture some features, maybe the eyes, we can use key points. And this is just a different shapes, ellipse, or we can use cuboids. Cuboids only, I think cuboids only can be helpful for 3D image, but we do not need it here. We can try brush. Brush is a tool to improve the contrast. We can try it here. Brush. Oh no. Brush. Cat. Shape. Click. I think we just have to click one. No. Oh, brush is used for image segmentation. Image segmentation, right? Right. If we use brush here, like this, then we can make it become a polygon. I forgot here. This one maybe. Brush. Polygon. No. Oh, I think I forgot how to use it. But brush is a tool that if you want to like more flexible to choose a part, and then it can like help you to do image segmentation. We can if you are interested, you can try that.
So one comment here, I hope everyone sees how difficult it is, right, to do segmentation job, to annotate and do hand segmentation. It's very labor intensive, and if you want to do it in an accurate way, it's very labor intensive and time consuming. So that is where the machine can help you. And Shanshan actually, in her previous slide, she mentioned about the SAM model, which is segment anything model, built by Meta and open sourced in March this year. So the model have great capacity in segmenting almost really everything in this world with great accuracy. Although it doesn't provide a label, but it gives you a variety of ways that you can segment different objects from an image. And then after that, if you want to do hand label, of course you could. But really, the heavy lifting job of separating pixels from each other has been very much accomplished by the SAM model. So we won't have to nowadays do the hand annotation of segmenting objects by ourselves, which is a very painful job. Yeah, feel free to go on.
Thank you. Last one I want show the new points. I'm not sure why we cannot, because we created a skeleton, but I'm not sure why we cannot see the skeleton here. Skeleton. Yes, let's go back and check. Animal. And I think we didn't set up skeleton. We didn't do this successfully. Try again. Skeleton. Image. Skeleton. Then we can plot the skeleton. This skeleton. And you should save, I think. Drag the point skeletons. Continue. It seems it's not successful. Oops. Okay, skeleton name. All right. Continue. Oh, I didn't give it a name, I think, previously. So we can do this again. This then continue this adding attribute. Oh, sure. The attribute I select test. Continue. Oh, here we can see the skeleton. Now we can try the skeleton.
So the skeleton works the same as the key point. Are they the same or they're different?
Different. Skeleton is like a template. For the key point, every image you have to like click. But if for the skeleton, you can define it under the project, and then we can use it directly here.
Oh, okay.
Now we have a skeleton, and this is the skeleton I draw. Then we can use here. Then we can just drag. Then okay. So it's more like it's like a template. And you can use, and you can also adjust. Now, can use another image.
I see. So it's more time saving and probably more accurate, than the key point, right? So if you were to label, say the retina of the eye, you probably use key point. Because it's a single point, right? But if you want to really get the rough shape, say the width of the eye and the height of the eye, then probably better to use skeleton.
I saw one like use of skeleton is if you annotate a video and people is working there, and the skeleton is like it can annotate people's pose. Like you can annotate their like legs, arms, and for each frame of the video, you can just like change a bit of the skeleton. Like this is one usage of skeleton I saw. So this is manual annotation. We have tried rectangle, polygon, polyline, key points, and skeleton. Next, we will try AI assisted annotation. Oh, also the change the job status. After we annotate all those jobs, we can click menu and change it to like complete if we complete. Then this one is for AI tool, AI assisted. We can check it here. They provided a lot of models for different tasks. We can check what models they provided. They also provided a same segmentation anything model, so we can use it directly. Use AI assisted annotation, and also some other models I'm not familiar with, but it's also an option. Like some it can like for SAM it's for image segmentation, but other tools, most of tools are for object detection, and the results are like rectangles. So here is the models. Then we can try. Okay. They have different 3 parts, like in interactor. Interactor, they only provided. Oh, this is the model they pre-installed. I will like introduce, like we can also install some models ourselves, so we can have more options. This is cat. We can also choose the label cat, And they have two models here. One is segment anything. Another, I'm not sure, but they can, the job performance, I feel is like similar. Then we can choose interact. Then we just click, then wait. It will automatically do the segment. Now we have it. We have, and click down. So we get the image segmentation by AI models. We can try another different models. And detector it used detector, I feel it's like models only have limited options. If we choose a model, I'm not familiar with model, but we can randomly choose one. Then it has limited labels we can use. It cannot, like, if they have 100 labels, that means we can only label 100 stuff. If there's like some 200 things, they cannot annotate for those models. That's
right.
why.
Yeah, so that you're exactly right. So some comments here. So the SAM model, which is by far the most advanced model nowadays to do segmentation, is very powerful in terms of being able to segment really almost everything. So it was built upon the ImageNet data with over 1 million images and over 1 billion hand annotations. So that is the scope of the work, right? So they build this model is huge and it has segment really well, but it doesn't provide label because it's just too much, right? To provide. Whereas, for example, Shanshan used here this YOLO model. So the YOLO model is much smaller. So it's probably a hundredth of the size of the SAM model. And the YOLO model is built for object detection, segmentation in real time. So it's smaller. It do it has the classification capacity as well. So it has a ground truth label for each of the segmented part of the image. But again, the model probably have less than 1,000 labels in total, right? So it's not everything. So usually people do that nowadays is link the SAM model with the YOLO model, so that to use SAM model for segmentation and then use YOLO model to do partial labeling. And of course, for those objects that are not very common and people have to label themselves, but at least they have the segmented image, right, to work with.
Right. So for this image, we do the image segmentation. It can, as Dr. say, like this model cannot do labeling, but we can do it. We can do it manually here. And when we choose this one, we already like choose predefined labels ourselves. So it's like combine the SAM with our manual label. So it's AI assisted. Then we can choose another detector model YOLO V7 and CAT. Then we can check. See. We didn't see why it seems it cannot recognize this CAT. Oh, I choose the car. Cannot. There's no car here. CAT here. CAT. Delete this. CAT. Annotate. Now it can identify the cat in the image. So there's other models you can choose. And the tracker is for video. We can try later when we use video data. So this is AI tools, AI assisted. It also provided OpenCV. OpenCV has some functions, but we can try, but I'm not sure what's used for. Like, it seems it can. Oh, this one is like we have click second time, third time, then it can automatically fill out the dots. That's how it works. And it can also adjust the dots, number of dots we want. And this is how it works. OpenCV tool. Another one, image. Oh, this image. On the OpenCV image, it can improve the contrast, image of contrast, you see. But I'm not sure why we have to do that. But it has this function. Another window is hidden here. We can also like change the brightness, contrast. ourselves of the image. So it's pretty. I think we have covered most of the steps. AI system, OpenCV, automatic. It also have services of autonomous annotation, but it's paid. We have to pay for it. But it's here. Here autonomous annotation, but we can click, but it will not run. So we have the window here, and we can choose a model for this job. Then also choose a model. It's like similar to our AI assisted, but it will do not the single image. It will do for the whole data set. But we cannot. It will not work because it's a paid feature.
Yeah, that's interesting. So they make this. Do you know the price for that? Does it have a price tag? You compare that to other like manual labeling tools.
You mean the price? We can check. We can check the price. I think. 33 per month. 33 per month, I guess. That's to upgrade it.
Right, and it doesn't matter how many you do. That's interesting, right? Because there's no human inside. It's just a completely autonomous annotation, right? So it's charged by months rather than by the number of images that it processes.
Right. It seems yes. Okay. Oh, now we can try like install different models. Here, image with autonomous annotation, image classification. Image classification is linked to the attributes we've mentioned, and analytic and monitoring. It's like we create a ground truth job, then we can do the analytics monitoring. And the top panel, we can see the top panel. We can see the 3 projects, and under the tasks, we can see all the tasks I've already created. And jobs is like subfolder of tasks. Like this is a jobs. And cloud storage, I want also mention cloud storage. It seems there were at least 2 options. One is AWS, Amazon Web Service, and Azure. Azure is like Microsoft, I guess. And this is like you can store if you have like a lot of images you want to annotate, you don't have to upload so many images to CVAT. You can connect your AWS or Azure with CVAT. Then you can annotate here. Then like save the annotated data back to this cloud. So it's like save your space and like improving efficiency one way. And then models, we can try model. Here, these models are pre-installed. So if you use CVAT, they already have these models, but we can add more models by more models from Hugging Face and RoboFlow. Can try Hugging Face. Here we can try RoboFlow first. So RoboFlow universe, and it can search. We can check image annotation, and we can search. Then this all those models, but some models they provided API key, some models do not. We can only install those with API key. Oh no text, it's image annotation. Face recognition, I think. That's where. That's the expression. I'm not sure, but we can just try one. See if they have API key. If they have API key, we can install them. No, it seems it has model here. So, API key. See here, this is API key. So this model, it has API key. We can first use a URL here, copy the URL, then go back to CVAT, the plus button, then pass the URL first. Then it will automatically recognize RoboFlow, this website. Then we have to paste the API key. API key here. Click API key. Then we can add a new model. We already added it if we check. So this is face from. This is just the new model we just added. Then if we do the image annotation again, but this will not work for our animal data set. But if we check, the model is already there. Okay.
You never know, right? You know, some models, some animals may frown at you.
Oh, we can try. We can try. Let's see. We have this one. Then AI tools. Then I think it's detector. Then the model face flow. Face. Then cat. Let's try if it works. What's the response?
I'm just kidding. I probably it won't work.
it doesn't work. You see, there's no objects detected. But that's we know we can add a model from a RoboFlow. Next, we will try add a model, install a model from Hugging Face. Hugging Face. It's different. It's different. Like when we use RoboFlow, it asks for API key, but when we use Hugging Face, it will ask for I forgot this. Token. It will ask for token. It's like different.
Right. So one comment here. The reason is RoboFlow, they borrowed models from a lot of different places. So they are not really designing their own models. And they were not integrating those models together. So each model may have a different API key depending on where the model comes from. Whereas the Hugging Face is a centralized platform. So you, as any developer of those models, when you train a model and upload on a Hugging Face, it belongs there. So Hugging Face has standardized every single model hosted there in that platform. So therefore, you only need to have a single access to Hugging Face to be able to access all the models. So that is the underlying reason.
Oh, wow. Thank you, Dr. So here, if we like open the Hugging Face website, then there's some like all those models. There's a section called Computer Vision. That's our interest. We may maybe image segmentation. We see image segmentation. We just choose randomly one model. Then go back to CVAT. Add model. We copy Hugging Face. Then copy. Then it will recognize Hugging Face. Then we have to have the token. For the token, we have to go to the setting. Then setting, there's access token. Then you can create your token here, or I can just copy my token, I think, then paste it here. See if we can. Now we should have a new model. It's this one. Is this one? Not sure if it's successful. NVIDIA.
Yeah, it is that one. Yeah.
Okay. So we installed a new model from Hugging Face. We can also use it. But I find it's kind of annoying because when I choose some like models randomly to add, but I don't want to keep them. I want to remove them. I didn't find a way to remove those models because it doesn't help a lot, but it's stated here. It's not looks messy, but I didn't find a way to remove them. Okay, models jobs image. I think this is I want to introduce about CVAT interface. We've tried manual annotation, AI-assisted annotation, automatic annotation we cannot choose. Then some models we can get to know more details about these models from their website. And after we complete the jobs, that's for this one. Suppose we finish it, then we can change it to complete. Do you want to count the job? Yes. Then we can export the job data set. Then it's based on the type of annotation you made, and also it's based on your purpose, what you are going to do with those data set. You can choose different types of exported format of the data set, and they have a tutorial about how to choose a data set. If you do classification, detection, segmentation, or key points, you could choose the corresponding format and also your purpose.
Right.
Then we
So one comment here, if Shanshan, if we could go back to, so this is important because a lot of annotation tools are lacking the flexibility to be exported, for the data to be exported in different formats. But here I do see the CVAT is very flexible. So really the first thing you want to think about, the format is what your model support, right? What kind of data that your model support. If you want to use, say, a YOLO model, then you should use the YOLO format as the export, because the YOLO model doesn't support VOC or a Pascal VOC or CVAT. So if you're using a different model, some models, a lot of models especially the previous models, they support COCO more than YOLO. So then you should export in the COCO format. So depending on the model you are going to train or fine tune, you probably need to choose a format that suits the model the best. And I can definitely see that the CVAT makes things easy because you are very flexible. You can basically convert that to any format that you want.
Thank you, Dr. Oh, before we try API, I tried API, but it was not very successful. Before we try API, we can try annotate video. We have video dataset. Can try video. The difference between video and image, I think, video is like also image, but it's like it's also image, but it's have additional like tool we can use, that is tracker. I think video can choose car. Yeah. So video, it's this video, it has it should show how many images it has. But this if we use this button, it's like each frame, we can see each frame. But if we use this one, it's like each step has 10 frames, like each step has 10 images. We can click. That's like a bigger step. And we can change the step. For the step, it's like each step has 10 frames. So you can see the change. So the next step is 50, and we can change the steps. Change steps. I think it should be. Steps review. I forgot where we can change, but we can change the steps. Standard attribute review, maybe review. No. Attribute annotation given. It's not. Fusion. No. I forgot, but we can change the steps. Now we can try a rectangle annotation. The difference is tracker. See, when we do the image, we choose shape. We can also choose shape here. We can use shape for this car. Now we have a shape object here, but this one is older. Then we can move to the next frame. See the shape disappear if we move to the next frame, but the tracker is still there. So we can create a tracker. No, this one. We can choose car, then choose tracker. Then we can choose this one, tracker. So we have a new tracker here. If we move to the next image, the tracker is still here. But the problem is we add a tracker, but it's not precise. If we play the video, you can see it's not there. It's not, when we move, it's not like follow the car, but we can adjust. We don't have to adjust every frame. We adjust only the steps. So now we are at the 0 point, then we go to the next step, that is 10. Then we, oh no, is this car? Next step, I'm not sure, maybe this car. Then we move the step here, and next step, the car is here. We move the tracker here. Then the next step, the car, I think the car disappeared, then we can change the status. Let's choose here, switch outside property. So the tracker is not there. Now we play this again. We can see how this object change. It will follow and disappear. So that's how we annotate a video, and how we annotate the video use tracker and adjust the tracker, and then if it disappears, we let it disappear. So this is video. The API, the API, it's very confusing, because I found they have like more than 20 APIs on their website either. You can use this, and they have 4 types. They categorize them into 4 types, like REST API, high-level API, PyTorch adapter, and auto annotation API. And for the REST API or low-level API, it seems it's used for, like, you can create an account and set your password, or do this kind of thing. And it seems if we only want to do the annotation, we do not want to design the software ourselves, REST API may be not our interest, and we do not have to like spend too much time on it. And high-level API, it seems it can do like some things similar to REST API, but its code is simpler. I try to understand, but it's not very successful when I try the API. We will focus on auto annotation API, but I also had some like issues when using it. But if we solve that issue, maybe we can do the auto annotation. So here, this is a collab codes. First, we have to I tried to use data set from my Google Drive, but I didn't do it. I didn't find a way to like get the data there. But we can show what we have. So first, we install some like package or library to use. They have a library SDK. They call the library SDK. So we install CVAT SDK, and if we want to use SDK PyTorch adapter, we install CVAT SDK PyTorch, and then we can import the library or modules before we use it. I didn't try I didn't try REST API, I tried a high-level API. Then also import some modules. Then this part, I use directly of their sample codes on the document. And this part is to create a task. We can run it here. This part is also one part. It takes me some time to figure out this code, because they say we have to change the local host. I didn't understand what is localhost, but finally I found it. Localhost is use like the website CVAT.ai. You just have to change localhost to CVAT AI, and then if you already have your CVAT account user. My username is Shanshan, and also my password. This is also my password. If you run it, it may change my interface. Then this part I just copy there. This is to create a new task. Then we can run it. It creates a new task, and it's supposed to also like upload some images. I want to try to upload images from my laptop. Also tried from upload images from my Google Drive. I'm not sure. Maybe these lines of codes may have some problems. It can create a new task, but it didn't upload an image. So if you want to try these codes, you have to figure out this. And then we can change the name. Now we use my task to be the task name. Then we can check the CVAT, the task. Here, now we have a new task called my task. So you can try those codes, but if you want to upload the image, you have to figure out this. I haven't. Then the PyTorch. So API is the way we interact with software, with the CVAT. So we can use the codes to create the task, or we can use PyTorch. It can like help us get some information. For this one, for this code, also use like the model, the sample code from the document. It created this one. It created a PyTorch model. Then I've run it, and then also every time we want to do something, we have to use our username and password. And this one is want to get how many images in that task. This one. Oh, here, this one. This is the task ID. This is my task, 342838. This one. This is my task 1. You can see here. This is a task ID. If you want to use another task, maybe this one, we can use the task we've tried today, cat. Then we can change it to cat ID. Then we run it again. I think we have 10 images, right? So it tells us we have 10 images. And this code, I didn't run successfully, so I hide those codes. Then we can move to auto annotation API. Because I'm not very sure, because if we use the interface, this is paid feature, but I'm not sure if this is a way. If we use codes, we do not have to pay, but we can do autonomous annotation. But it was not very successful. I did, so we import some modules. Then they have a define function, I think, touch vision detection function here. And this is definition. And I copy paste from the website, and we can like to do some changes. They use like label spec, And I think we can change label spec to skeleton label spec or key points to change the annotation type. So they have label scap. Where's label scap? The label spec here. I think just a change. If you want to use another annotation, you can change accordingly to this function, different types, and also the shape. For this default, they use rectangle. My guessing is like using change the rectangle to other shapes, so we can use different annotations. So this is like maybe the template of define a function. Then we can use this to run our annotation. This part, this supposed to be to run the autonomous annotation, but I haven't figured out the problem because I only changed the like it can run previously successfully, can connect it to my account and interact with my account. I'm not sure why it cannot be successful here. And it told me that's because of the like cannot identify the image, but it should can, because if I can run the code, if it can like tell me there are 10 images there, and can help me create a new task. I'm not sure why it's not successful here. I emailed them. I emailed them, but they haven't given me a solution. If they tell me, I will update with you. But there's still something we can thing we can learn here. So we also use our a username, then account, then use a task ID, change the task ID here. This is something we can change. They used the faster RCNN. This is a model, right? Model that we can change. And I found the website. Think we can use it. Key point segmentation. There's like different other models we can try to replace this model, so we can use different ones. And another before I got this warning, I got another warning because when I use this model has more than 80 labels. Every time I run the model, it tells me your project doesn't have this label. You have to add this label to run this to run this model. So for example, because I run the task 1. No, not task 1, project 1. Because all the labels are on the project 1. You see, I added all those labels in that model. If we delete one, let's delete one. Then we run this model again. It will tell me label bot is not in the data set. I think there's two things. If we have a large data set of images we want to label it, it will not take much time, maybe only 10 or 20 minutes. You added this label, like it can still help you save time. Another is they provided an option. They actually provided an option of allow unmatched label equals true. So even your project does not have all the labels in the model, you can still run the codes. But my problem is I don't know where I can add this line. But this line should be added somewhere in the code, so it will not tell you you don't have this label. So this what I learned from this code. First, we can ignore the labels, or we can, if you don't know, you can add all those labels. It will not take you much time. Second is we can change the model, and it's still not very successful, but if I can figure it out, we'll share the updates. And the last part is command line interface. They provided this, but their document, provides some code, but it's not Python. It's not Python. I'm not sure what language they use, but it seems also like a simple way to interact with CVAT, but it did not use Python. I tried find another way to use CLI, command line interface, is to use ChatGPT to translate the language to Python language, but it's not very successful. I successfully installed some like library, but it can, maybe there's something wrong with the translated language. So that's all I have. I think let me check. This is a REST API. This is the document image segmentation. Okay. Okay. So that's all I want to present about CVAT, but I have some questions for Dr. An and for you all, because when I do this task, I was thinking why we have to do this, because there are so many like big models. I've talked with Dr. An. There are so many like models can do this task. So why we want to do our do another model, and the purpose we want to annotate is to get the training data, but I think we cannot use the autonomous annotated data directly, because if we my understanding is if we do autonomous annotation without a human intervention, that means we treat those autonomous annotated data as ground truth, but that means the software we use, the model we use is 100% accuracy. How can we improve it if we treat it as like 100%? Only if we have some manual annotation or manual annotation, AI assisted annotation, we can improve the training data, improve the quality. That's why we can have a better model. So even we have this, we have the autonomous annotation tools, but it's not used for us to do automatically and don't do any annotation. We can use it to like give us a rough results, but we still have to check this data to improve the data. That's the way we can get, like, we can train our own model and get a better model. So to recap, what we've learned today, we focused on image labeling, and we've talked about 3 tasks of computer vision tasks: object detection, image classification, and image segmentation. And we introduced 4 basic annotation types: polygon, polyline, rectangle, key points, and then we introduced some tools, commercial tools, open source tools, and we focus on CVAT and do it like manually AI assisted. And we tried APIs, but it was not very successful. So that's all we have for today.
Wonderful, wonderful. Thank you so much, Shanshan, for taking that time to dig into a lot of really useful suggestions, and the tutorial is well received. So it really opened, probably, as far as myself is concerned, it really opened my eyes regarding what CVAT could do. So previously, I briefly used CVAT before, and the functionality you described today were mostly not there at that time. So it seems like the CVAT has been completely revamped to include state-of-the-art models, and make it not only an annotation tool, but really a platform of hosting a variety of models to facilitate autonomous or semi-autonomous labeling. So this is fantastic. So hopefully, many people today may use try to build image classification or object detection models. Will use the CVAT model, CVAT labeling tools.
I have last question.
Yeah,
Dr. An, Could you please share like the difference between CVAT and VGG image annotation? Because you tried view. What's the difference between
right. I actually no, Yui has Yui and she used the tools, the VIA tools before. But no, when you talk about CVAT, we would never want to go back to VIA tools because it's very preliminary. It has a lot of bugs, and it took me a long time to handwrite some of the code to deal with the bugs. So it's no fun, right? A lot of hard work was with no fun. So I think though Yu probably she would agree with me that CVAT is a lot more advanced than the VIA. So we never want to go back. And to address, yeah, Shema, agree as well, right? Yeah. So to address your previous questions, right, regarding why we need to do that. No, there are two reasons at least. One is that not every object has been classified well, right? There's a new object that not classified at all or classified with poor quality that we want to do our own work. For example, to identify objects used in developing nations, right? For example, a piece of soap, right? The soap used in Philippines is so different than the soap used in the United States. We have great models to identify soaps in the United States because the model have seen millions of images on soap, right? But not actually for soap used in Africa or soap in Philippines. So therefore, we need to develop a model on those less common, not as common, but not well used images or objects. And the second is we can't really deploy large models to end devices. A lot of time, our way is to find a model that can just classify, for example, cats from dogs, right? And it's overkill to use SAM model. SAM model is great, but no, it's too large, right? To be embedded in your phone or used in other edge devices. So you want a much smaller model. In this case, yes, we want to retrain the model so the model can just do one task that we care about. So those are the two reasons. And the second and the third comments is I completely agree with you that we can't really trust the large models. We have to, as a human, to supervise the learning approach and try to stay in the loop, so that we can make correction, we can make judgments, right? We can make sure that the model's predictions are realistic, are good. So the machine can help us, but not totally replace us. So we have to supervise the machine to learn better. So machine can take care of probably 90% of the job, but the other 10% we have to do ourselves, right? So that is the reason why we can't really completely automate the task. We have to use the AI tools to facilitate our work, to boost our productivity, but not to completely replace us. Yeah, so that's all great comments. Any questions from any of our audience here? No? Okay.
I may have one last question. Because if you want to like have your like develop a new model, we've seen there are so many options we can like, I'm not sure, like algorithm or something. You can, for example, if we have 20 options, how will you do, like if you want to do for the 20 options, what will you do? You will try like all the 21s and compare which one is better, or you can find a way to narrow down to maybe 5, then you can focus on 5 and compare.
Right. It usually depends on the time and the computation power you have, right? You can try more, but well, if you are time limited or computation resource limited, you try a few. Probably the most recent one is the one that you think are more promising, right? Depending on, for example, if you want to train a model to identify, for example, different cells, right, in biology, then you don't want to use a general model. You want to start with a model that is trained on biological data. So that model probably going to work better than a general model. So depending on one is the structure, the architecture model, and second is where the model, what data the model will use to train, and you want that data to be as close as to your task, right? So and then there's also another thing I want to mention, but I forgot. But anyway, I hope you all get the idea of now we are really in the era of AI assisted research, right? Now I remember there's one thing I want to mention that I don't think we want to use the API to do annotation, because annotation is really we want to visualize that. We want to probably use a software to do that rather than to use code to access that. So if you want to automate the task, yes, you write Python code or other code to access the API. That's a great way. But if you want to do manual labeling, I would highly recommend that we stick to the software because it's just more intuitive for us to drag and click than writing code. And plus, I would say, if you want to use the existing models, open source models, the SAM model is open source, all the YOLO models are open source. If you use those models to do completely automate annotation, you don't need actually the CVAT. You just read the model documentation and then you go from there. It's very simple. For example, all the Hugging Face models have a very, very standardized way to interact with, especially making inferences. So you don't need the CVAT at all. If you want to use YOLO model, you don't need CVAT. They have great documentation that you can read, and you can just use Python to access the API. The reason why you interact with CVAT is really to use the software, I guess, to use AI facilitate manual labelings. I see that is the true value of CVAT. So if you don't want to pay the $30, you don't need to pay, right? Because all the models they use, they are open source, right? So you can directly access those models. They demand some kind of programming skills, and understand the API, but it's not that difficult. You should be able to figure out probably in a few hours or in a few days. Yeah, so anything that and one more thing I want to mention is that in 2 weeks, I've asked she to make a presentation following Shanshan's presentation. So her talk is to focus on the intersection between SAM model and YOLO models, okay? Because I do see there's a synergy between those models. If we can combine those models together, we can do semi-automated annotation with great precision. So she is going to offer us a tutorial on SAM's model and YOLO model, and then how we can use those two models, possibly combine them together to do some fantastic things. So that is scheduled in 2 weeks. So anything else? We really thank Shanshan for your great contribution. That's fantastic. I personally learned a lot. So anything we want to discuss before we dismiss this meeting? Okay, great.
Ask a question.
Yeah, go ahead.
Yeah, I think Peiqi asked a question in the chat box.
Oh, okay. Sorry, I didn't see that. Oh, Peiqi asked, yes, I wonder, are there any specific weaknesses of this model? For instance, it performs worse on some specific projects, such as image of camouflage. Peiqi, can you explain what model you are thinking?
Yeah, I'm thinking about those annotations and labeling stuff. We have label all those things even by man in hand. However, because the reason I'm asking the question is because of the spectrogram those graph we have working for. I wonder, especially for some specific type, are there any weakness of this, this model? Like, are there anything probably we would now considering use this method to do it? Or and also, are there any specific field, for sure, we already know it is really good for labeling. So I'm trying to find out when will we avoid using this model instead of using other Greek models or methods.
That's a great question. Probably we don't have a clear answer. The best is to try, right? To see, how the model perform, right? If the model give you, if a classification problem model give you 50% of accuracy, then the model is no good, right? But we don't really know. One thing is you could think about how close your data looks like the training data to train those models. If they are sufficiently close, then the model should do a good job in general, right? But it's very distant, that your object have never been used to train the model at all, then maybe the model may perform terribly, right? But we can't really say for sure. We have to probably just try a few models, see their performances. But well, the worst case would be you have to hand annotate yourself, right? Which would be painful and labor intensive. But if that's the way we have to do that, then we will do that. So that is part of research. Not everything can be automated, right? We are in a better road already, right? Even a few years ago, we have to do all these hand annotations ourselves, right? It's really painful. But nowadays, well, look at in 2 or 3 years, we have those fantastic tools to help us. Those tools are not perfect. They're going to make mistakes. But I would say, I would argue it's better, a lot better than not without those tools. Okay, wonderful. Okay, so let's stop here. Yeah, that's all for today, and we'll see each other in 2 weeks. Bye, everyone.